Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at how to find trig ratios, right triangle trigonometry for geometry. We're going to be looking for the sine, cosine, and tangents of specified angles of a right triangle. To get us started, we're going to be taking a look at an acronym that can help us to generate the three formulas that we need to find the three trig ratios, okay? So this acronym is known as SohCahToa. Very important in the fundamentals of trigonometry. So SohCahToa is the acronym I'm going to use. So let's say we have this right triangle right here and the reference angle is theta. What does SohCahToa help us to determine? So let's say we have a triangle like this. So if this is the reference angle, that means that this side opposite the reference angle will be the opposite. The side opposite a 90-degree angle is the hypotenuse, or the longest side of the triangle. And then the other side is the adjacent. Okay? So the first three letters tells us that sine of the specified reference angle theta is equal to opposite over hypotenuse. Okay? So the O in SohCahToa represents opposite, and the H represents hypotenuse. Okay? All right, and then next is C-A-H. So cosine theta. A represents adjacent, H represents hypotenuse. So means cosine of this reference angle right here is adjacent over hypotenuse. All right. Another thing to keep in mind is that the way it's written and the way you say it is different. Okay, so as a function, it's sin, sin, or cos cos, but this is pronounced as sine, and this is pronounced as cosine. All right, and then the last one, toa, T-O-A, tells us T is for tan, the tan of the reference angle, O is for opposite, divided by adjacent. All right, so that's what SohCahToa serves in helping us generate these three trig ratios. So what you need to find all three trig ratios is you just need the three sides of a right triangle and a specified reference angle. It's going to be one of the two acute angles, and then you can generate the trig ratios for the specified angle. All right, so the instructions for the examples we're working on are for us to find the sine, cosine, and tangent for angle A in the given triangles. Okay, so for question number 1, let's say we have triangle ABC in this configuration, and then this side here is 4 and 3. All right, so we have to find the sine, cosine, and tangent of angle A. So this is a reference angle that we're going to be looking at. In order for us to find the sine, cosine, and tangent, we need all three sides, okay? So this is a reference angle. That means that the side opposite the reference angle is going to be the opposite, all right? So this side right here is your opposite. And then the side opposite the 90-degree angle is your hypotenuse. And then this side right here is your adjacent. Okay, let's also name it using letters. So let's say the side opposite B, the adjacent, let's say that's B. All right, and let's call this A, and then let's call this C. So with this setup that we have right here, we know that our opposite, which is A, is 3. Our adjacent B is 4, but our hypotenuse is unknown. Okay, so in order to be able to write all three trig ratios, we need to find hypotenuse, find the hypotenuse. All right, so let's go ahead and find the hypotenuse, which is C. Okay, all right, let's do it. So in order to do that, we have a right triangle. The formula that relates to three sides of a right triangle is the Pythagorean theorem. So we have a squared plus b squared equals c squared. All right, so we plug in the sides we know and the sides that we need. So A is, what did we say A was? A is 3. So we have 3 squared plus B. B is 4. 4 squared is equal to C squared. if you know your Pythagorean triples, you should already know what C is. But let's just act like we don't know and then just solve it, okay? So we'll work through this. 3 squared is 9. We have 9 plus 4 squared is 4 times 4, 16 equals C squared. 9 plus 16 is 25 equals C squared. So to get C by itself, you take the square root of both sides. Okay? And then you get C is equal to 5. That goes your answer right there. So that's the hypotenuse. The hypotenuse is 5 units long. Now we are ready to find the 3 trig ratios. Let's start with sine. Sine of angle A. We're going to use SohCahToa again. So let's put it up here. SohCahToa. So for sine, we're using the first 3, right? So sine of A is opposite of a hypotenuse. So that's going to be opposite is 3 over the hypotenuse, which is 5. All right? So sine A is 3 over 5. Cosine. Cosine A is your adjacent. That's this one right here, Ka. Adjacent over hypotenuse. So that's going to give us adjacent is 4 over a hypotenuse, which is 5. And then the last one is tan. SohCahToa tan. Tan of angle A is opposite over adjacent. All right, the opposite is 3 over the adjacent, which is 4. All right, so there goes your 3 trig ratios for angle A. All right, let's take a look at question number 2. So for number 2, let's say we have a situation where we have, this is A, B, C. And then this side is root 41. And this side is 5. So we have to find all 3 trig ratios for this triangle for angle A. All right, so this is our reference angle again. So we're going to take a look at the side that's opposite it. That will be your opposite. All right, this is 5. Let's call that A. And then this side right here, the side that's opposite the 90-degree angle, the longest side of the triangle, is your hypotenuse. All right, so let's call that C. And then this other side, the third side, is the adjacent, which is B, and we don't know what it is, question mark. All right, so let's write down what we know and what we need. So we know that the opposite, which is A, is 5. The hypotenuse, which is C, is root 41. And then your adjacent is unknown. So what we're going to do is we need to find the adjacent, which is the B measure. All right, so let's do it. So we're going to use the Pythagorean theorem again. A squared plus B squared equals C squared. In problem 1, we were looking for the hypotenuse. Now we're going to be looking for one of the legs. So let's substitute. A is 5. So 5 squared plus B squared. We don't know what B is, so use a variable. And then C squared is root 41 raised to the second power. Okay, so we're going to solve this quadratic equation. 5 squared is 25 plus B squared. So the square and square root are inverse operations. So when you compose them with each other, they cancel each other out. So that becomes 41. To get B by itself, we're going to subtract 25 from both sides of the equation. Subtract 25, subtract 25. Okay. And that will give us B squared, which is equal to 41 minus 25 is 16. And then to get B by itself, you take the square root of both sides. And then your answer B is going to be 4. All right, now let us find out what the 3 trig ratios are. Since we now know what the third side is, the B measure is now 4. We know what that is. Okay, so we're going to use SohCahToa again. So sine of your reference angle A is opposite over hypotenuse. That's what SO means, opposite over hypotenuse. So the opposite is 5 over root 41. Okay, so now we have a radical in the denominator, so we have to simplify that by rationalizing the denominator. So to do that, we just multiply root 41 to the numerator and the denominator. Okay, it's multiplied by the radical component of the denominator. That will give you a situation where you have the square of a square root in the denominator position, and it can cancel out. So this becomes 5 root 41 over, since you're multiplying two identical roots, it's the square roots cancel each other out, so you just have 41. All right, so there goes your square root. So let me show you the work here. So root 41 times root 41 will give you the square root of 41 square. Square and square root are inverses. They cancel each other out, so you get 41. Okay, so the rule basically is root A times root A is always going to be A. Okay, let's move on to the cosine piece. So cosine A, Ka, is adjacent over hypotenuse. All right, so the adjacent is 4 divided by the hypotenuse, root 41. So we're going to have to rationalize the denominator. So multiply by root 41, top and bottom. You always rationalize if you have a square root term in the denominator position. Okay, so when we rationalize, the top is going to be 4 root 41, and then the denominator will be root 41 times root 41. We're going to work it out here. Is root 41 square, which is just 41 because the square and the square roots cancel out. Last but not the least is tan A. Tan A is going to be opposite over adjacent. Okay, so the opposite is 5 and your adjacent is 4. And there goes your final answer for tan. So ladies and gentlemen, this is basically how you find the three trig functions for right triangles. Thanks so much for taking the time to watch this presentation. Really appreciate it. Don't forget to support our channel with your likes, comments, and subscriptions. Tons of support resources can be found on Mathgotserved.com. Do check it out. Thanks again for watching, and we'll see you in the next video. Goodbye.